We're going to look at the final prediction, the implementation here. And this is the final piece of the code where specifically we get our Bitcoin API from Crypto Compare. And this is the API key. And we're getting the 2000 previous values starting from today. And we're getting every hour. So this API gets the data every hour. The other API that you saw got it every day. So it's more accurate, but we can only get up to 2000 data points. If you go any further, you'll get an error. We're using 4 input neurons here. And these are the outputs, 0 or 1, buy or sell. So current data prediction, that's the price that we want to predict. And this one is the current price. Now, if we have a prediction, so I'm just going to say, when do we buy and when do we sell? Well, if the future value is higher than the current value, that means we should buy because the future value is higher. So we want to buy now. So basically, if this value is greater than 0, it's 1, which means buy. And if this value is negative, that means we should sell. So this value is going to be 0. That's just how we're going to structure these values. And here we set up our train X and train Y. This value is offset by 1 at the end. -1 means last index. So we're going to take the whole data set except for the last index. And for Y, this is our prediction. This is what we want to predict. So we're going to remove the first value and take all the values starting from index 1. And that means that we're always going to have a value that's going to be, when we compare train X to train Y is always 1 value ahead. In the same case goes for test X and test Y. And here is our neural network that we're going to be using. And here's our trainer. And this function takes in our data, and it allows us to train with the train X data, and then it will store the text X and test Y data. And here is our optimizer, and here we use the BFGS algorithm. But of course, we could use other algorithms. So we also, this is BFGS. We can also use Newton CG, LFBGS, TNC, so on and so forth. So if we could just take another optimizer. We can read about, so these are just optimizations of gradient descent. These are just better methodologies than gradient descent, and you can read about them here. If you want to switch, and you can just change that here. And then it just switches the optimizer. So I'm going to make sure that I'm not printing anything because that stops the graph from showing. And the orange line is the prediction here. So this is actually something that can easily happen. So we've said predict either 0 or 1, and it's just saying I'm always going to predict 0, and that's just going to optimize the value. And because of the Bitcoin price is such a complicated fluctuation, it's very difficult actually to get it right, whether it's going to predict 0 or 1. So this can very easily happen. We get stuck at a local minimum, and it's unfortunately unable to give us a nice prediction. And we see in other cases that there are other, it's non-deterministic, these values, because we randomize the weights in the beginning. And we also see that it does actually predict other things, and it can even predict 2.0. So we need to make it optimized so that it can't actually predict 2.0. But you see that it is very non-deterministic, this invest. There's a lot of things that we can do to make this better. One of the things, of course, would be to get more data instead of only 2,000 data points. And to also have more options for input neurons there. So here we actually get a cost of 0.23 error at the end. This is outputted from our optimization minimization function here, the LBFGS algorithm. And if we wanted to plot the cost as well, we could just create another subplot and do that. And this self.testj is actually going to give us that. We just need to plot out this self.testj, which is the cost of our testing function. Want to see that? But this one has an error of about 25 to 23%. So just play around with these values. You can change the number of input neurons here. So volume 2, volume from, current data, previous data. You can change all of these to just different accuracies. I welcome you to try all these different values here. So that's that will allow us to predict, create a trading algorithm that says, should we buy or sell at different points? Thank you very much for your attention.